Hi, welcome to Math 63, Unit 2, Lecture 2, Part 3, Linear Equations in One Variable. All right, today we're talking about linear equations in one variable. A linear equation is an equation like, well, any of these three. The thing that makes it linear is all of the x's. The highest power that you have is 1. So you have x's and constants. There are no x squareds, there's nothing like that, and there's no, we're not dividing by x ever, nothing like that. It's always just number times x or just single numbers, and that's it. Okay, so that's what makes it linear. There's only one variable, and since we have a linear equation in one variable, these are very easy to solve, at least in the beginning. And then they get more complicated. All right, but what we have here, the first step is a single step equation. All right, all we need to do is think, hey, I'm taking a number and I'm multiplying it by 2 to get 8. How do I undo multiplication, right? Well, the opposite of multiplication is division, right? Just as the opposite of addition is subtraction, they're opposites. So I am going to undo this multiplication through division. I am going to divide both sides of the equation by 2. Now that's the rule. Whatever you do to one side of the equation, you have to do to the other side, because that's what equals means, right? If we did one thing to one side and didn't do it to the other, we wouldn't be maintaining equality. Okay, so dividing both sides by 2 will leave me with x on this side and 4 on this side, and indeed 4 times 2 is 8. Okay, so that one was relatively simple. Let's try this one. This one's now a two-step equation. What we have to be careful with a two-step equation is that we undo things in the proper order. So basically it's going to be reverse bed mass order. So a thing that I do is I'll pick a number in my head and plug it in for x. Say it's 2, right? And I will ignore that it's an equation for a moment. I'm going to go 2 times 3, okay, so that's 6, and then plus 5 to get 11. So the order that I went was I did the multiplication and then the adding, because that's how our order of operations works. So from there, I know that I need to undo it in the opposite order. So I'm going to subtract 5 from both sides. So I'm just write a little note down here that I'm subtracting 5. Okay, and so when I subtract 5 from this side, the plus 5 and the minus 5 disappear, and I'm left with 3x. On this side, I have 14 minus 5, which gives me 9. Okay, so now I'm back to basically the same thing that I had with this equation over here. It's a one-step. So now I say, okay, I'm multiplying by 3, so I'm going to divide both sides by 3 to isolate x, get x by itself. And now I have 9 divided by 3, x is 3. Okay, cool. Now here we have a multi-step equation. Okay, our first thing to do here is get all of the variables on one side of the equation, and we'll do that by adding or subtracting, and get all of the constants on the other side of the equation. So let's start by getting all of the variables on the one side. So I'm going to subtract a single x from this side, and so since I'm subtracting an x here, I have to subtract the x over here. So these will cancel, and I'm left with 19 over here, and 5x minus x is 4x, and then plus 7. Okay, so now I have a two-step problem like we had before, and it's the same. If you want, pause the video and see if you can get the answer, and then watch and see if you get the same answer. That would be a good practice. So here we go. Hopefully you just paused the video and you've got your answer. Let's see if I get it right according to you. Subtract 7 from both sides, so this cancels, and now I've got 4x is equal to 19 minus 7 is 12. All right, and now divide both sides by 4. So that gives me x on this side, and that gives me 3 on this side. Did I get it right? I sure hope so. If not, send me an email. Okay, good. Let's try some more. Okay, here's some examples of how linear equations can get scary looking. All right. Rather than freaking out though, just remember these are just numbers. They're not here to hurt you. Okay? We know how to deal with fractions, we know how to deal with decimals. Everything that we're about to do is the exact same as what we've done before. Okay? So with fractions, a thing that you could do is multiply the whole equation by the common denominator. In this case, that would be 12, because 3 goes into 12, 6 goes into 12, and 4 goes into 12. If you multiply the whole equation by that, so every single term, okay, then you will get an equation without fractions, and that might be easier to work with. Okay, so that's one thing that we could do. Or we could just do the equation exactly the way we did before and not freak out about the fractions. I'm going to do it that way because I'm a rebel, but if you would like to see how to do this by multiplying through by 12, look in the textbook. All right, it's in there. Okay, this example is right from the textbook. Okay, so what I want to do is I want to collect all of my variables on one side of the equation, and I want to collect all of the constants on the other. So I'm going to subtract, I'm just choosing x over 4. I could choose x over 3, there's no reason I couldn't, but I'm just deciding I'm going to choose that one. So that gives me x over 3 minus x over 4 minus 1/12 is equal to 1/6, because these canceled. Okay, now I'm going to add 1/12 to both sides. So what I have now is x over 3 minus x over 4 is equal to 1/6 plus 1/12. Okay. So now I have a third x minus a quarter x. I want to find a common denominator. My common denominator is going to be 12. So I need to multiply 3 times 4, so I'll multiply the x times 4. And I need to multiply this 4 times 3, and I need to multiply this x times 3. So this is going to end up being 4x minus 3x all over 12. Right? You know that I can do a share a denominator here because it's common to both. Okay, cool. Now I'm adding these two fractions. Once again, 12 is my common denominator. Okay, I'm going to multiply 6 by 2, so I need to multiply the 1 by 2. So I have 2 plus 1 over 12. So now I have 4x minus 3x on this side. 4x minus 3, last I checked, is 1x. So this is just x over 12, which is going to be equal to 3 over 12. I could now multiply both sides by 12 and get x is equal to 3. Okay, so just to show you can do everything with fractions and it all works out fine. If you look in the textbook, they will show you that you could have done this multiplying by 12 step at the beginning, and then it would just have changed it right back to the sort of question that we've done before. But heck, I figure fractions are okay to work with. Why not try it? So there's an example of doing it without fractions, without dealing with the fractions until the end. Okay, cool. Now let's try an example with decimals. Okay? Ooh, decimals scary. No, decimals are going to be fine here. Okay? So like with the fractions, an option would be to multiply everything by 100 to get rid of the decimals, but that just seems extreme. So I'm just going to do the same sort of thing where I'm just going to deal with the decimals, because I don't think that's much of a problem. So I'm going to multiply through to distribute there and there. So 0.45 times 2x is going to be 0.9x. And now 0.45 times 3 is, oh, okay, this is getting to be a calculator moment, so let me get out the calculator. Finding my calculator, here we go. Okay, so clearing the calculator. Okay, so 0.45 times 3 is equal to, oh, okay, 1.35. All right, minus 2.55, because we're only dealing with the brackets first. And now on this side, we're distributing, so 0.6 times 3x is going to be 1.8x, right? Because 6 times 3 is 18. Move the decimal place once. And then 0.6 times 5 is going to be 3. Because 6 times 5 is 30, and you move the decimal place once. All right, good. So now I'm going to collect everything. Let's see, just looking here, I would like to keep my coefficient on x positive if I could, so I'm going to subtract the 0.9x from both sides. All right, and you know what, I'm going to speed things up a little. I'm going to also get rid of my constant over here at once, so I'm going to say plus 3 and plus 3. So this disappears on this side, and I have 1.35 minus 2.55 plus 3 is equal to, okay, we got 1.8x minus 0.9x, so that's going to be positive 0.9x. Let's now do this calculation. Let's see, we've got, you know what, there's a lot of decimals there. This is a good time for another calculator moment. So we have, clearing everything, 1.35 minus 2.55 plus 3. So that gives me 1.8 is equal to 0.9 times x. Okay, so now I have 1.8 and 0.9x. This is multiplication here, so I'm just going to divide by 0.9 on that side and 0.9 on this side. We cancel out over here, so this is going to be x, which is good, that's what we're hoping for. And on this side, it's going to be, I know it's going to be 2, but let's just check. Divided by 0.9 is, oh good, 2. So here we have 2 is equal to x. You could write that as x is equal to 2 if you like, but it doesn't really matter what the order is for our equality. We are good. All right, so that is how to solve linear equations in a single variable. This was a pretty short lecture, so there will be a lot of examples. If you feel like you want to go practice some examples before class, it's not a bad idea. There's a ton in the textbook. All right, I will see you in class.